suppose that we've replaced one of the resistors in our voltage divider with a transistor. We put in, really this is an Nmos transistor. So we put that in here, and we'll just assume that our resistor here that we have is just a fixed 10K. Doesn't super duper matter right now. It's 10K. And really there's two scenarios we can have here. We could have a 0 applied here, or we could have a 1 applied here. And so really when I say 1, I could 1 and 0 I could really mean 0 volts or ground and 5 volts. But no, they really mean just a logical 0 or a logical 1. So what we want to look at is the voltage on this middle point relative to ground. Same with this guy here. Voltage on this middle point relative to ground. So first, if we have 0 volts, what's going on with this transistor here? Well, since it's an NMOS, we know that if we have 0 volts here, this transistor is going to be open. So we'll say this transistor is open. It's like there's a switch here, and the switch is open. And so this is not exactly the best way to think about it, but it's the way I always think about it, and it works for me. It's kind of this signal flow idea, where we see that if ground were to try and get to this point, ground wouldn't be able to do that. Ground wouldn't be able to get there because there's this open circuit here. 5 volts, on the other hand, or a logical 1, can get through here. It's limited by the resistor, but 5 volts can connect through here. So we've kind of got this type of thing going on here. Also, right, we know that this is really an infinity ohm resistor, right? So we could apply our voltage divider thing, figure out what goes on here. But what we find out is that we end up with 5 volts on the output, or a logical 1. Now let's look at this case here. We've got 5 volts applied to an NMOS transistor, or a 1. And so that means that this switch is quote-unquote closed, meaning that current can flow through here. So that kind of means, not exactly, but the way I like to think of it is ground has a nice solid path to this point here. And 5 volts does have a path there, but it has to go through a resistor. So once again, maybe borderline electrical engineering heresy, but the way I think of this is that this signal is kind of weaker because it's going through this resistor there. And you can run your voltage divider equation assuming that this is 0 ohms, and you'll still be able to find out that we end up with 0 volts here, right? 0 volts, or this is a logical 0. So let's look at our behavior here. We have, so we're going to say this is our input, and this is our out. So if our in is a 0, our output appears to be a 1. If it's a 1, it appears to be a 0. And this is an inverter.